Hey aviators, welcome back. In this session we're going to be talking about VFR flight following. Now there's certain vital things that you're going to need in order to get this accomplished. So this one might be a little bit longer than the other sessions. The reason why is because we're going to be going in depth, step by step, of how to fill out the VFR navigation log, as well as going over some stuff on the sectional. So let's go ahead and get started with the vital information. Let's go ahead and just jump right into it. First thing I hope you have right now is your POH. Your POH may not look like this, but if you're flying whatever airplane you're going to be flying, it's vital that you're going to need the performance data of your airplane in order to calculate the top of climb, the top of descent, your flight time, your fuel burn, all that good stuff. That's going to be required in order to do your flight plan. So number one thing, make sure you have your pilot operating handbook. Next thing you're going to want to do is get a sectional chart. Now, get a sectional to learn how to do this. Once you can do this by pencil and paper, then we can probably go over to SkyVector, and we'll be going back and forth between the sectional and SkyVector just so we can clean things up on the actual SkyVector, so you can see what I mean, because it is kind of hard to see pencil on here. So we'll be getting a little bit more going back and forth between the sectional and SkyVector. The other thing you're going to want to have is the handy dandy flight computer, your E6B. There's so many people that are so scared of this thing, but we're going to go over this step by step, and then hopefully by the end of the video you're going to be like, oh well, that was easy. Another thing too, you're going to need a plotter. So I have the old-fashioned plotter. There are ones that you can take the center and you can actually dial it or whatever. I think that's kind of cheating in my opinion. I think these ones are the more difficult ones, so that's why I actually prefer to train using one of these, because if you can use one of these, you can use the easier one. So have a E6B, your plotter. And lastly, we're going to need a VFR navigation log. Now the one I'm using is, I just Googled the VFR navigation log, and I think the very first one is Jepson. Let's go ahead and check that out. Okay, so here we are on the Google app. I'm going to type in VFR, oh look at that, it's already done. VFR flight plan PDF. Just look, and here we go. The very first one right here is Jepson. And there you are right here, there you have it. So I'm going to go ahead and you can go ahead and pause the video right now, so you can actually go ahead and look this up. Go ahead and download it, or you can print this out, and I'll see you back when you come back. Okay, so welcome back. Hopefully right now you have one of these sitting out in front of you. Now the second page, I forgot to mention, the second page is the old FAA chart that you used to fill out when you actually filed your VFR flight plans. We're no longer using the FAA chart. It's now moved on to the iCal version, and that's going to be probably in a separate video. In fact, yeah, that'll be in a separate video. But for now, let's just concentrate on this very first page. All right. So how this is going to go in a particular order. You want to first route your route on the sectional. So you're going to be needing one of these to see where you want to go, obviously. Once you have your route, you're going to have information on there. For example, headings, you're going to have the distances and all that. However, what you're going to need on top of that is, okay, well, now that I have my distances, will my plane make it there? That's why you're going to need the POH. Once you get the aircraft information on there, plus the wind correction and all that good stuff, now you know how much fuel you're going to burn and how much fuel is required. So once all that's done, then you do the weight and balance, which hopefully you watched that video before this one. If not, go ahead and you can watch it after this one, and it's no big deal. But you don't really want to do your weight and balance first, because you have no idea how much fuel you're going to be that you're going to need. So for example, let's say you're flying a 172. The maximum payload on there is 53 gallons usable. So 53 times 6 is going to be 318. So 318 pounds, and let's say you have some extra luggage that, well, guess what? I can't even bring the extra luggage because the weight of the whole weight of the airplane exceeds that of the aircraft's limitations. However, if you find that, well, I don't really need 318 pounds of fuel, I can actually maybe take half tanks. Oh, now I can actually take the extra luggage with me. So that's why you want to do your routing. You want to make sure you do all your calculations first on here, and then when this is done, then you'll know for sure how much fuel you're going to need, and then you can do your weight and balance after. So let's go ahead and look at this really quick. Okay, so what we're looking at here is the VFR navigation log. Now, we're going to be going over this obviously a lot more in depth. Don't really be intimidated by all these little squares. I know it looks like a big old Excel sheet, but we're just going to start from the top and down. This is just going to be a brief description of what we're looking at here. That way, when we start filling this stuff out, you're going to be a little bit more familiar of what all this stuff is. So starting from the top down, let's say up here, your aircraft tail number, so your N numbered. So let's say you're flying, you know, Cessna November 1234 Bravo. So you'll put 1234 Bravo, whatever your tail number is here. Notes, this is completely up to you. You have all the freedom in the world to put whatever you want up here. And as we go through, when we finish up, I'm going to actually give you my recommendations of what you should put up here. In this column right here, this is what you're going to be putting your route information. So today we're actually going to be planning a route from Ormond Beach in Florida to Gainesville. So this very first airport right here would be the airport identifier for Ormond Beach. And then after that, when we take off, we're going to be climbing to a certain altitude. Well, it's going to take us a certain distance to get to that altitude, a certain distance and time to get to that altitude. So once we get there, that's going to be our top of climb, or TOC. So you're going to start off with your starting airport, then TOC, and then your next navigation point, or your top of descent. But let's say we're going to have a couple of checkpoints in between Ormond and Gainesville. So this is how you would list it out. You would put your Ormond Beach, top of climb, checkpoint, or airport, whatever you're flying over, in order to navigate yourself to Gainesville. Because remember, this is VFR, so you're actually going to be looking out of your window to find these checkpoints. So for example, once you're at your altitude, your first checkpoint can, let's say, be a bridge or a big building. So that's what you would put inside of here. Or let's say it's another airport that you're navigating to fly over. So you put the aircraft identification, or let's say a VOR. So that's the information that would go here. The next over here is VOR. Now notice it has ident and then frequency. So our VOR for Ormond is going to be 112.6. So 112.6 for your VOR would go on the top. I'm sorry, your 112.6 would be in the frequency on the bottom, and then on the top would be the ident. So if you have like for example, a G1000 or something like that you can actually see the ident frequency, then or the name, then you can actually see OMN if you put in 112.6, or 116.2 if you put in Gainesville, the Gatorsville VOR. So that's what these two, so you have a big space here, and let's say this is a VOR. So right up here on the top, you would put, for example, the VOR ident name, and then you put the frequency of that will be in this block right here. And this is how all of the others work too. So, and I'll get back to this, what I mean by what I just said. So moving over here next is going to be the course route. So where are you going when we line up our points on the map? You know, where is that going? Is that north, south, east, west, northwest? What heading is that? And that's going to be our course route right here. Altitude, whatever altitude that you're going to be flying at, that's pretty self-explanatory. So at this point, if you want to be at 5,500 feet, then you can put, you know, 050 or 055, which translates to 5,500, or you can write out the whole 5,500 in this little box. I recommend that you abbreviate because they don't really give you a lot of space in these blocks. Next, just like how I mentioned here, how it shows how you should be writing in these boxes. Say how you have a blank spot over another small little blank, and then another small over another small blank. Well, this is kind of like how it's representing up here. So just like this, you have your VOR ident freak, ident freak, ident freak, ident freak, ident freak, all the way down. This course route, course route, course route, course route. This one, altitude, 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 all the way down. Now when we get over here, okay, what do we put in this block? What do we put in that block? What do we put in this block? Well, if you look right up here, it tells you exactly how to fill out these little blocks. So in the top left block, in the top left, you have DIR, which is your wind direction. So you put your wind direction over here and you slide it over. What do you put in this block? Slide it over. Oh, it's wind velocity. So let's say the winds were coming at 090 at 10 knots. You put 090 for your direction, and the velocity is 10 knots. So 090, 10. Okay, so finally, what do we put in this larger block right down here? So we just go right down here, and then we have the temperature. And it's the same exact thing all the way down. So direction, velocity, temp, direction, velocity, temp, direction, velocity, temp, all the way down. Okay. Next, we have our true airspeed, which is calibrated airspeed correction corrected for non-standard temperature or non-standard temperatures. This is what you're going to have in this one, and we're going to get into that once we get in our POH. That's where we're going to find this information. Now, when we start getting into wind correction and variation lines, if you watched the DV Mono or the Compass Errors videos, you probably know a little bit about the variation and the deviation in the compass errors. So that's what we're going to be going in this. That's what we're going to be filling in this blocks right here. However, you can't get the wind correction angle or anything like that unless you have the wind direction velocity. Okay, so these numbers are going to be from whatever you have over here. Now, another thing, just like how it says, you know, direction, velocity, temp, all the way down. These ones are going to be working the same thing. Now, these are a little bit confusing to some. So on the top here, you're going to have true course. This right here, this block represents this block right here. This block represents this one for that one for that one, and so on and so forth. So the true course is literally going to be the same number you have here. This is your true course. Okay, not your magnetic, because that's what you're going to have right there. Your true course. Okay, because we didn't do our magnetic yet. Now, once we have our true course number in here, right down here, we're going to have our wind correction angle, and we're going to be using the E6B in order to get that information. And now with that, we're going to have the true heading. So how are we going to get the true heading is, let's say we have our true course and our wind correction angle is, let's say, -5, for example. So you're going to have that true course -5 equals this number. So you're going to put whatever these two numbers equal, you're going to put it up here. Then next, you're going to have your variation lines. You're going to put that below the true heading. So you're going to put that in there, and then whatever this plus or minus this is going to equal your magnetic heading, which is this right here. So you see how it kind of zigzags. It's going to go, let me see if I can do this left-handed. So you're going to go fill this out, do this, whatever this and this equals, it's going to go up here. Whatever this and this equals is going to go up there. And then finally, you have your magnetic heading, and then your deviation. Now, your deviation is going to be, you're going to get that from your compass card in your airplane. So let's say whatever this magnetic heading is, let's say it's 360, and you look on your compass card on your aircraft, and it says, well, for 360, the corrected deviation is, 358. So you would put -2 for 360, and then you would, whatever that equals, finally goes in this block right here. Sorry, I'm trying to do this left-handed. So that is how this works right here. Okay. Finally, we have our distance. Again, leg is on top. Distance remaining, REM is for remaining, is on the bottom. Now notice you have this little blank square up here. If you have the total distance of your route, that's the total distance that you would put in this block right here. Okay, so since we're in this little leg right here, so the leg, let's say that leg was, I don't know, 10 miles. So you put 10 right here, and then 10 minus whatever you had in the total. Let's say it's 100 miles. So if you flew 10 miles, well, the remaining is going to be 90. So you put 10 to 90. and then you continue doing that all the way down. Ground speed. Ground speed, we're also going to be using the E6B to get our ground speed. Now we get into this ACT and EST. So EST is estimated ground speed, because we all know that weather changes, the wind changes once we get up in the air. So that's going to be your estimated based off of the data that you have currently. That's why it's going to be estimated. Now once you get up in the air, you're going to write the actual ground speed, which is going to be going below your estimated one. So estimated is on top, actual is on the bottom. And it's going to be the same thing for over here too once we get into the times. And I'll explain exactly how we can get the ground speed, an easy way how to get your actual in the air, because you're definitely going to need this skill in order to when you're doing your check ride. It's going to make life a heck of a lot easier. All right, lastly, moving on over here, this little area over here. So we have ETE, so time takeoff. Let's say we took off at 8 in the morning. So on this leg, based off our airspeed, the wind correction, if we get a headwind or tailwind, how long is it going to take us, based off the information that we have now on the ground, how long is it going to take us to get there? Well, that's what the estimated time en route, ETE, estimated time en route is. So let's say we estimated for it to say, I don't know, 5 minutes. So you put 5 minutes on there, or 5:00, however you want to write that on there. And then when you actually get to your navigation point, let's say it actually took you, I don't know, 5 minutes and 30 seconds. So you put 5:30 on there. So hey, now you have an extra, you have a little bit of a tailwind there. Okay, and up here you have, so this is estimated time en route. This is estimated time arrival. So you'd actually put the time there. So if we said we took off at 8 o'clock, our estimated time en route was 10 minutes. That means on this little area, you're going to put 8:10. And the same thing down here for actual time arrival. If it took you, 5 minutes extra, then you're going to put, 8:15. If it took you 5 minutes extra or whatever. So that's what would go in the actual. And this is very important too, because if you plotted a route that did the maximum performance of your aircraft, and you notice that you have a headwind all of a sudden, you may want to probably land a little bit before them, because you're probably not going to make it. So if you have an extra, headwind that you didn't really expect, that's why it's very important to always fill out the actual, so you can tell if you're going to make it there on time, or if you need to land before there, pick up some more fuel, or whatever. So lastly, we have the gallons per hour up here. So we have gallons per hour. Now this is the information that you're going to find on your POH. Okay, and this one right here. Moving on down, we have fuel, the fuel used, and then the fuel remaining. So let's say on the very first one, we used 5 gallons of fuel. So right here, you can probably put a -5 right there, and then 5 minus whatever fuel that you put it in the aircraft. Let's say we topped it out and we have 53 gallons usable. So let's say we had, so we're going to put -5 gallons, and then the -5 from 53 is going to be 48. So remaining, you would put 48 right here, and then you do the same thing all the way down. So now you can probably understand what we have going on right here. Now down here we have the totals, so you can have the total. So this right here, and this should actually literally be the same. There's the distance up here, let's say 200 miles, and down here you should have obviously 200 miles. Over here, total time. This right here, you can put the total time, estimated time of the whole flight. So if it's going to be 2 hours, you can actually put that down here. And of course, the total fuel that's used. Now this is very important. Once you have this number, then you can go to your weight and balance. And over here we have our ATIS information for the airports, our departure and destination airport. So if we're leaving Ormond, we're going to get the current information from Ormond Beach Airport, which is going to be right here. So we need the ATIS code, the ceiling visibility, wind, altimeter, approach, runway, all that good stuff. And then in our Gainesville, we can actually add this information probably while we're in the air as we're flying over there, because obviously you may not be able to get the current ATIS code while you get there if your flight is probably longer than an hour. Moving down here, you can get the valuable information from each of the airports. Let's say, you know, if you have normally for flight would definitely already have all this for you, but it's also good to have all of this stuff, especially when you're doing your check ride. It's best to have all of this already filled out. That way your examiner it has a little bit more confidence in you. It's like, oh, okay, well, if you already researched all this stuff and now have all this stuff filled out, good, you know. That's less questions that they may ask you about if you already have this filled out. All right, so with that being said, let's go ahead and start plotting on our sectional chart. Okay, so now we're going to do our route. I've kind of already done it in pencil. I don't know if you can see that, but I'm actually going to do this in darker pen. So once we're going to do our route, and so here is Ormond Beach. I'm sorry, Ormond Beach is going to be right here. And again, I will go back over this on SkyVector so it's a little bit easier to see. But I want you to see how I'm going to be doing this on the actual sectional, because this is going to be a little bit more realistic of what you can expect during your check ride. So the first thing we're going to do is find our route. So here's Ormond Beach right here. I keep pointing the flag. Here's Ormond Beach right here. And Gainesville is going to be right here, way up here. Let me go ahead and see if I can center this a little bit better so you can see this a little bit better here. All right. So when we're flying a VFR, now when you're picking your points, you want to have something that is really close. You want to pick something that you're flying right over it, because when you fly right over something, you can just look right out your window and see, okay, cool, I'm right over that point right now. I can put in a time right there, right this second. However, if you're flying over here, you're going over here, but you're picking up nav point way over here, you're going to be flying, and you're not going to be able to tell when exactly that point is exactly to your 3 o'clock or 9 o'clock. However, if you fly right over something, you're going to have that much more of an accurate time. So definitely pick things that you're going to be flying over. All right, so let's start with Ormond Beach. So Ormond Beach is going to be over there. So I'm going to take my handy dandy little plotter, and I'm going to try to stay out of the way of the camera here. All right, so here is Ormond Beach right here, and since Flagler is going to be right there, I'm going to draw a line from here right to Flagler. Let me make sure that this is nice, and there we go. So right over to Flagler. There we go. And that's my very first point, because as soon as I take off, I can see it right there. All right. Next point. Again, here's Gainesville right over here. Let's see. And the reason why I didn't go just straight over here is because there's nothing really I can use that's within 10 miles. So this is the closest one I have, so that's why I picked this one. On a really, really clear day, you can probably fly west and possibly go over here Lake Crescent, follow this little river up here, and then you can see Palatka. Oh, there's Palatka. And then you can keep on flying westbound. There's a little road down here. You can follow that road. But you notice how it's kind of like just you're kind of going all over the place, right? So that's why I chose to just go straight up here to Flagler. Now Flagler, oh my, there's nothing. I need to go west, but there's nothing over here to look at, or is there? If you look really closely, there's some power lines right there. Let me go ahead and zoom this in just a little bit. So right here, there's power lines right there. And if you are ever flying in this area, these power lines, you can't miss them. And there's a point where they actually go north-northwest, and then they have a sharp turn straight to the west. Right there, that point, when the power lines turn, that's going to be my checkpoint. So I'm going to make this a checkpoint. And right after Flagler, I should be up on my altitude by now. So this right here, I'm going to draw another line straight there, and that's going to be my other checkpoint. Okay, so let me go ahead and zoom back out here now. All right, now moving on over. Next is Palatka. can see Palatka. Now Palatka is just a little bit more over than 10 miles. However, there's other things you can see, like for example this big bridge that you can see. Now again, it is a little bit more than 10 miles. So how can we actually find this? Look at these power lines. If you follow these power lines, it brings you right toward that bridge. And once you can see the bridge, Palatka is just literally right there. So that's going to be our next waypoint right there, Palatka. So put a point there, draw a line there. And another thing that I'm going to do, I'm going to draw this right here. Okay, so now that we've got a Palatka, what I normally do here is, remember how I was saying earlier how we can use the VORs as a nav aid. So look at what we have over here in Gainesville. Oh, we have a compass rose, which means we have a VOR. So we have a VOR frequency right here, 116.2. And our identifier for Gainesville is GNV. So what we're going to be doing, once we get to Palatka, what we can do is we can actually tune to this VOR and fly directly toward that VOR. Now, why would we want to have that as an extra? Well, just for last resort, let's say if you fly over here, you get a little lost, or let's say an unfortunate event happened, and I don't know, we're in the clouds or somehow, and we need to find Gainesville. And you can use the same method no matter where you're at, right? So let's say we're going to go back to our VFR navigation log. So right here we left from Ormond to Flagler to our first nav point. So we actually can plug that in right up here. So we have Ormond, our top of climb, Flagler, our first nav point, which is our little power line, little curve right there, and then Palatka. Now Palatka, right here, just like we have VOR ident, we can tune to GNV, which is the ident, and the frequency is 116.2. 116.2. The identifier is GNV right there. So once we do fly over there, we can have that right there in our aid. And on top of that, which you can put over on the little side, this little space right here, what I'd probably recommend you do is, once you are tuned to that VOR, what course do you need to fly in order to keep that CDI right in the center? So in this case, if you draw a line just straight to the west here, it's pretty close to 270. So on here, you can actually put, once you're at Palatka, you can put the VOR information on here, and a little side note, or up here on the little notes, you can put, a course, fly 270, and that'll take you right to Gainesville. Now moving along here, after that, our next nav point here is going to be Melrose. Again, that's like another 10 miles or so. It's a little bit over 10 miles, but it's a good nav point that we can use. Also, while we're flying in this direction, not only can we make sure that the VOR CDI is centered if we are using the VOR. If not, then look at this side road right here. We can use this side road, make sure that this road is always to our left right here, which is pretty easy to see. Now moving on, next is going to be, of course, our destination airport, which is Gainesville. Now in between Melrose and Gainesville, we're going to do what's called our top of descent, and we're going to get into exactly how we're going to configure that and calculate that. But for now, we're going to take a break. We're going to take a 15-minute break. When we come back from that break, what we're going to be doing is we're going to figure out how to use this to get our distances as well as our true course headings, and then from there we can figure out about the variation lines and the wind correction and all that good stuff here in the next 15 minutes. So go ahead and hit the pause right now, and I'll see you back in here in 15 minutes. All right, and welcome back. We're going to be going to the sectional, but real quick, just in case if you couldn't really see this, let's go over to SkyVector, and let's see what that looks like in SkyVector, and just so a small little tutorial on how to navigate around SkyVector to help you out with the flight planning. Okay, and here is SkyVector. So we're going to zoom in here in case you couldn't really see the sectional on the camera. This is going to be a little bit better to see. And you can also use this to check to see if you have the right headings, to see if you have the right distances, and all that good stuff. So right over here, I'm going to go over to SkyVector. I'm going to go ahead and hit flight plan. Departure, I'm going to put KOMN. It's already filled in for me, so KOMN. And the destination is going to be KGNV. That is the destination. I'm going to go ahead and hit the little X mark here. Now I'm going to zoom out, and notice it's just a straight magenta line. Right, but this is not the route that we just did on our sectional. So what we can do, what's so great about SkyVector, let's go ahead and zoom in here. You can go ahead and hover the mouse over the magenta line anywhere you want, and you can click and drag this right over the airport. Once you release the mouse, we can go ahead, and this is our first nav point, so you can hit plan, and there you go. Look at that, it gives you the heading and the distance right there. Our next nav point, we're going to go and slide up here, is, remember these little power lines right here? There they are right there, and there's that sharp westerly turn right there on the power lines. So let's go ahead and drag that right up here, and we're going to release. Now what's going to happen when you release where it's not over an airport or a section, it's going to think that you made a mistake. So when I release the mouse, notice how it says the very first one, plan Frontier. Since Frontier is the closest nav point to this, it thinks that it wants me to go over here, which I do not. And the next one is this this BKENI intersection, and that's another thing, and that's going to be, it's really close. Where's it at? That's somewhere around here. I can't really see it right now. I think I need to go on the low IFR chart. But anyway, so if you want to get a custom GPS point, well, then you do the last one, which is GPS. So that's the one we're going to pick right there. And look at that. There it is. Okay, now our next one was Palatka. So let's drag this up to Palatka. We're going to select Palatka. Next, we're going to be going on over here. We're going to, here's Melrose right here. Bring this down to Melrose. And then lastly, there it is. Once we zoom out here, now we can see, hopefully you can see this a little bit better. And this is what your line should look like on your sectional. Okay, so now we are back. So now now that we got our routes done, and before we start using our plotter, let's go ahead and fill out our VFR nav log of what we have, the information that we have so far, so we're not playing catch up. So right here, what I have is Ormond for our top of climb. And in order to get our top of climb, we're going to be needing our PUH for that. So Ormond, top of climb, Ormond, top of climb, to on our way to Flagler, which is Flagler. Flagler, we got the power lines next. Flagler, there's the power lines. After the power lines, we have our 28J, which is Palatka. So we have Palatka right here. And remember, when we're at Palatka, that's when we can actually tune to our VOR, which is why I have our VOR, a little aid right there, 116.2, which is Gainesville's 116.2. Okay, and again, once we found out exactly where to fly, the heading we need to fly to get to Gainesville from here, we can actually write it right here, and that's completely optional. You don't really have to, but that's something I'd recommend. Next is Melrose. And we got Melrose right there. And then between Melrose and Gainesville, we have to start descending, right? Our top of descent, which is why I have TOD, top of descent. And then finally our destination, which is KGNV. Now, how do we use this, this funky looking plotter? So, first of all, you want to make sure you're on the right scale, right? So this is the WAC scale. We're not using the WAC. We're not using the world chart. We're using the sectional chart, right? So you want to make sure you're on this one. Okay, and then on top of that, you always want to be using the down here, which is the nautical mile segment, right? So we're going to see we're going to put our marker right here. So here's Ormond. Our very first point is going to be Flagler. So let's go ahead and measure that. And that's going to be around 11 miles. Look at that, see 11 miles right there. So that's going to be our 11 miles. Now, however, there's going to be a top of climb in there, right? So for now, let's just put in an arrow. You don't really have to do this, but I'm just going to put 10 miles between Ormond and Flagler, okay? Now, between Flagler and the power lines, how much is that going to be? So let's go ahead and do that. Flaglet and the power lines, that's going to be roughly around, I want to say 12.5 miles. Let's just say 12 miles. So again, distance. So between here and here is going to be 12 miles. So we're going to find our distance, our leg, and find in order to go to K-fin to the power lines is going to be 12. So distance is going to be 12. So we're going to put 12 right over here. Now we're going to find out, and notice how it goes, these are in between these 2 points. Why? Well, the altitude between this point and this point is going to be what? The altitude or distance or whatever between this point and this point is going to be what? What are you flying? What are you doing in between these 2 points? What are you doing in between these 2 points? In between these 2 points. That's why they're kind of a little offset. So what's happening in between these points is going to go in this line right here. So that's why they're a little offset right there. Now we're going to find out the distance between the power line and Palatka. So let's go ahead and measure that. Here's a power line. And here's Palatka. So it's going to be around, let's see. So I would say, let's see, 10, 15, 16, maybe 16. Let's just make it 17 just to make it easier. So I'm going to put 17 miles. Again, 17. Again, between the power line and 28J is 17. Now between 28J and Melrose is going to be, and we just rinse and repeat. Rinse and repeat. And we're going to back this up on SkyVector too so we can see. So that's about 14 miles. Okay, and now we're going to get into the top of descent all the way down there. So over Melrose is going to be between, I want to say, let's say that's like another 17 miles. Between Melrose and Gainesville. Now let's go ahead and let's see what is the distance for our top of climb. So first thing we got to do is we're going to find out what our altitude, what are we climbing to? And this goes back to our VFR altitudes. So anything that's going to be westbound, we need to fly at an even 1,000 feet plus 500. So let's go ahead and fly at 4,500 feet. Let's go ahead and select that. So at our altitude, since our altitude, we don't really have an altitude over here in between here because we're in the middle of climbing, all right? So in the altitude, I won't even worry about putting a number there. I'll just go ahead and put an arrow going up. And the same thing for top of descent too. So once we get to that altitude, between our top of climb and Flagler, we should be at our top altitude, which is 4,500 feet. So I'm going to put 0.45, which is 4,500 feet, all the way down. Here, I'm sorry, between the top of descent down to Gainesville, we're not going to be at a specific set altitude because we're going to be descending. So on this one, I'm going to put an arrow going down. And now notice we kind of skipped our little course route. So let's go ahead and knock that out real quick. So let me put that off to the side. Courses. Now this is where people get confused. And it's definitely not that difficult. So hopefully after this you'll be like, oh, well, that was easy. So how we're going to do this is the line that we created, which is right there. We're going to put this on, put the ruler, line it up on that line. Now notice that the plotter has a hole right in the center. We're going to put that hole over the true north lines. You see these lines right here? And here's another line right there. It's kind of hard to see. You're going to put this hole, this center hole, over any one of these lines. Okay? So let's do those two steps first. So put the ruler, bottom ruler over the line right here. Cool. Now here, can you kind of see how the true north line is to the right of it? So now we can't just move the hole over the line because, oh look, now our ruler is not touching this course anymore. So bring it back down here and slide this down until that hole is over the line and it's on this line right there. Now what we're going to do is, now that it's over this line, and now we're going to get our true course. This line right here, our true course line, is going to intersect two of these numbers right over here on this outer edge of this half circle. Okay, so if we know, so if this is 360, this is 270, and we're going kind of this way, in this direction, it's going to be, the heading is going to be in between, somewhere between 360 and 270, right? So we're going to put this over here again, slide this back down, and then we're going to find what heading on this little half circle does this true course line intersect. So I'm going to look really close here, and it intersects, let's say I'm looking at the line between 160 and 150, but that doesn't make any sense, right? Because we're not heading in the direction of between 160 and 150. If we move down here a little bit, you'll see these other numbers. It's somewhere between 340 and 330. That makes a little bit more sense. So we're going to be using those two numbers. So I'm going to follow the true course line, and it intersects somewhere between, I want to say, and it kind of counts backwards too. So this is like, so each tick here, so it's 330. If I do a tick over, it's 331, 332, 334, 335, which is the middle line here, 336, 337, 338, 339, 340. And we're using these bottom numbers here because we're heading in a direction of 330 and 340. We're not going in the direction of 160, 150. That wouldn't make any sense. That's why we're not using these numbers. Okay, so this line intersects somewhere between, I wouldn't say 3, 3, 4. It's not right in the middle, but it's just one tick over. So this heading is going to be 3, 3, 4. So I'm going to put on this 3, 3, 4. Let's try another one. Going to do the same thing here. Again, line this bottom line right here, or you can use this. I mean, it doesn't really matter. You can use this line, you can use that line. It all works the same. So the bottom of the ruler, move it there. Put this on any one of the true north lines, or if you're doing something like this, you can do it on the easterly, westerly, the latitude lines. Again, we're going to put this line right underneath the ruler right here. We're going to slide this on over until this center hole is right over any longitudinal line. Make sure that this is still there. Hold it right there and follow that longitudinal up or down, doesn't really matter. And what heading does that longitudinal line intersect on this half circle right there? So I'm going to count the ticks over. So I'm going to use these bottom two numbers, the 310 and 320, because that makes sense. I'm heading in the 310 and 320 heading. I'm not going to be using these top outside numbers, these top outside heading numbers here, because I'm not flying at heading 140 or 130 in between those two headings. That would make no sense. That would be the opposite direction where I'm trying to go. So I'm going to be using these bottom two numbers. So moving straight, this is 310. I'm going to moving over until it intersects this longitudinal line. So here's 310, 311, 312, 313, 314. Looks about 314 right there. So I'm going to use 314. And it's the next one between K-fin and, so let's say 314. The reason why this is wrong is because, remember, this is one heading right here. This is one heading. It's going to be right there, all one heading. So our top of climb is going to be roughly around here somewhere, but we're still going in the same heading. So these two numbers should always be the same. So 334, this is also going to be 334. Okay, now when I'm turning, now you can see the heading change right there as you're turning. and you do the same exact thing all the way down. I'll go ahead and pre-fill these out for you real quick. Really quick, before, you may run into this issue, this sometimes too. You got it all lined up, and you're trying to find a longitudinal line. You put the circle over the here's the longitudinal line. It's kind of hard to see, but there it is. I'm following it up. Put this right over there, and I'm following up, and I'm off the map. What do I do? So what you can do in this case, you can just flip it on over and do this same thing. So I'm gonna line it up on this course right here. Cool, it's lined up. There's my hole, there's my center hole, my longitudinal line. It's kind of hard to see, but it's right going through here. I'm gonna slide this over until that is over the line. It is really hard to see. Let me see. Oh, there it is. Okay. It's right about there. Okay, and then it's kind of hard. Let me slide this up a little bit so you can see a little bit better. But make sure that this is lined up right there. The center hole is centered on a longitudinal line. Follow the longitudinal line and find out what heading that longitudinal line intersects. In the same exact thing. I don't want to use these bottom numbers here because this is 090 and 100. That's going that way. We are going westbound, right? So if I use the inner numbers, oh, look at that, 280 and 270. Cool. So I use the same thing. Use this. I'm just going to try to figure out which longitudinal lines it intersects. So it actually looks like 280. Looks like 280. I'm just going to use 280. So, and here is going to be, let's see, parallel lines to there is going to be 280. Okay, same thing down here. I'm going to throw, so from Palatka to Melrose. I'm not going to use this longitudinal line because when I slide it over there, it's really kind of hard to see. So I'm just going to slide it over to another longitudinal line. Same exact thing. As long as this is accurate, then you can go over any longitudinal line. It's every longitudinal line is going to intersect these headings the same exact way as long as you have this lined up correctly. So I'm going to this longitudinal line. I can see a little bit better, so I'm going to use that one. Put this on that line right there. Make sure it is centered right there. Cool. Now, what heading does this intersect? This longitudinal line intersects. It's gonna, let's see, I see 270. Moving this way, it counts upwards towards 280. So each tick mark is gonna equal 1. So let's see, 270, 271, 272. I'm gonna use 272. So that's why I have 272 right there. Now, the Melrose to Gainesville, this is all going to be the same heading, just the same as this right here was the same heading. So Melrose to Gainesville, we're going to do the same thing. Melrose, Gainesville, I'm going to use that same longitudinal line, which is right here. So let's see, move this right on over that line, recenter these. Again, Melrose, Gainesville, make sure that that's straight. Make sure that this hole is centered on any longitudinal line and find out what heading that longitudinal line intersects, and it looks like 275. So I'm going to say 275, and it's going to go all the way to Gainesville. Whoops, 275. So that is that right there. Now let's look on how we're going to get the winds aloft in the temperature information. All right, so here we're going to find out our winds aloft information. So here we are. You can Google AWC, or Aviation Weather Center, and we're going to be looking at our forecast. So we're going to be looking here. We're going to be scrolling down to winds and temps. Now, since I'm in the Florida area, I'm going to go ahead and scroll down. And of course, you're going to pick wherever you're at, and you're going to get the winds aloft information from whatever area that you're going to be that you pick. I'm in Florida, so I'm going to pick this right here. We're going to click this, and this is going to be our winds aloft chart right here. Now, the closest one that we're going to be flying to, the closest weather station that we're going to be flying to, is this one right here, Jacksonville. Now, we're not really concerned about all of these other numbers right here because we're not going to be flying at 9,000 feet. This column is the winds over near Jacksonville at 9,000 feet. 12,000, or sorry, 12,000 feet. You want to go to Miami, and you want to fly at 18,000 feet over Miami. Well, here's Miami. So at 18,000 feet over Miami, the winds are going to be 330 at 28 knots, and the temperature is going to be negative 10 degrees Celsius. So that's how you're going to read this chart. But for now, let's just concentrate on Jacksonville. So at 3,000, the wind's going to be 110 at 14 knots. So we can jot that information down, and we're also going to jot down the 6,000 feet. Why? Because we're going to be flying in between 3,000 and 6,000 feet. We can use a process called interpolation. So what we literally do is we just take the average of the two data, and then that is how we fill in the information for the altitude that we are going to be flying at for our flight plan. Another thing that we can do is we can get the observations for the airport, because we can't get the weather. Notice on the flight plan, it also asks for the winds and temps on the ground as well. Well, if you go to the winds aloft, it starts off at 3,000 feet, like 3,000 feet. You know, the airport's not 3,000 feet. So what are the winds doing, you know, at the ground? You know, up to 3,000 feet. Well, that way, in order to get that information, we can go to the observations, go to METARs. We can type in the aircraft code right here. So let's go to KOMN, and look at there. There's the weather information right there. So we can use this information in order to get our winds right here, and our temperature is going to be right here as well. There's our temperature, and there's our dew point right there, and of course our altimeter setting, and then we can do the same thing for Gainesville as well. Now you can get the Gainesville, so we can actually get that right now. So KGNV, we can get that right now. However, this is only good for 1 hour. So what I'd recommend is you can actually you can fill it in on your flight plan. However, I wouldn't really rely on this information until you actually get the accurate ATIS information when you get closer and closer to your destination airport. Okay, so I went ahead and plugged in the data that we got from our AWC website. Now, if you're wondering how I got this information, so 030 at 10, temperature is 24. I got that from the METAR. This right here is I pretty much interpolated. So that 3,000, it was if you remember, it was 110 at 14 knots, and then at 6,000 it was 060 at 6 knots and 12 degrees. Now we know that every 1,000 feet you go, it drops 2 degrees Celsius, right? So if it is 12 degrees at 6,000, at 5,000 it's going to be 14 degrees. At 4,000 it's going to be 16 degrees. It's going to be climbing now that we're going downwards, right? So at 16, I just used 16,000 at, I'm sorry, I just used the 14,000, the temperature at 14,000, which is going to be 16 degrees. So that's how I got the 16 right here. Also, I interpolated through the 080 and 10. Now, the wind at 3,000 feet was 110, and the speed at 6,000 feet was 060. So 060, 070, 080, 090, 100, and 110. So what I just did is I just picked a middle there, and that's how I got 080. And the same thing for the velocity. It was at 3,000 feet, it was 14 knots. At 6,000 feet, it was 6 knots. So I just picked a middle, and that's how I got 10 knots there. And I just use those same numbers all the way down, because all of these are all within the Jacksonville weather station area. Now, if you go a little bit more west, you can actually use Tallahassee's if you want to use that, but I just went ahead and just made it easier and just to use these. And this last one, these numbers here, I got off of the Gainesville METAR. And again, I wouldn't really rely on this too much, because again, this could change as you're going. And in fact, all of these can change, which is why it's so important that we use these actual data right there as well. All right, so now before we move on, we're going to get our true air speeds, we're going to get our distances for top of climbs, and we're also going to find out how we do our top of descent. But before we do that, we're going to take another break, and I'll see you back in 15 minutes. Okay, welcome back to the break. So now we're going to be looking into the POH Section 5, or Chapter 5. So I'm going to be using my Cessna 172 POH. Now I'm going to go to Section 5. Now your POH may look a little bit different, but ideally the chapter is going to be exactly the same. So example, Section 3 is going to be your emergency procedures. Section 4 should be normal procedures. Section 5 should be performance. 6 should be weight and balance, you know. So all of this should be roughly around the same. So let's go to Section 5, and you're going to flip to short field takeoff distance. Now, why does it not do the normal takeoff distance? Well, this information is a little bit more important than just your normal takeoff. Okay, you have the normal takeoff information, cool, you can put that on there, but it's a little bit more important to see the maximum performance takeoff of your aircraft, and that's why it shows this one and not just normal takeoff. So you're not going to see normal, you're going to see only short field distance. Now, maximum weight 2550. And it's also going to have some other weights here too. Now, a good thing about the performance section is that everything's in order. So if you were to take off, after you take off, then what do? You climb, right? So, and that's what is next, the climb information. After you climb, you level off and you cruise. So after that, you have your cruise performance. After that, then you're going to start descending to land. Here's all the endurance information, and then here we go. We have our short field landing distance, because this is our maximum. This is the maximum performance of our aircraft at landing on a very short field. And again, you're not going to have your normal landing information, because again, this is a little bit more important than your than a normal landing. That's why that's here. So that's how this is. This how this section is constructed. So we're not going to be worried about the distance, takeoff distance, or anything like that. This kind of information is normally on your weight and balance charts. So we're not going to be worried about that at the moment. We're going to go ahead and flip over, and we're going to be, this is what we're going to be interested in right here. So let's go ahead and zoom in here. I'm going to zoom in just a little bit here. All right. So how are we going to read this right here? So let's go ahead and break this down. So here's our pressure, altitude, the temperature in Celsius. Now this, not all POHs have this. This is very convenient to have. Because this is all standard. So at 4,000 feet, what's the normal standard temperature up there? Oh, it's 7 degrees. What's the normal standard temperature at 3,000 degrees? Oh, it's 7. So again, sea level, every 1,000 feet you go up, you lose 2 degrees. You lose 2 degrees. So this is a nice little table to have. But again, not all POHs have this. Next, our climb speed. That's going to be important too. I don't know why I'm covering it up, but anyway. So next is our climb speed. So if we're going to be climbing, let's see, up to 4,000 feet, then our normal climb speed is going to be 73 knots, 73 knots, 73 knots. So this doesn't really change on all that much unless you're really high up in there. Then moving on, our rate of climb. I never really use this one, to be honest, but if you want to know what your rate of climb is, there it is. We're going to be interested in these 3 columns right here. So our altitude is going to be 4,500 feet. That's what we're climbing to. And notice there's no 4,500 feet. There's 4,000 and then there's 5,000. So again, just like how we did over here at the 4,000 feet and getting the wind velocity, the direction, and the temp, we interpolated, right? There's that word again, interpolate. So, oops, I actually missed something here. 0, 0. Let me go ahead and fill that in. There we go. There we go. All right, so moving on here. So we're over here. So 4,000, between 4,000 and 500. So we're going to go over here, and let me go ahead and get this back. I knew I got this for a reason. All right. So 5,000 feet it takes 8 minutes. If we climb, this is our normal performance chart for our airplane. To get to 5,000 feet, it's going to take us 8 minutes. And we're going to be using 1.9 gallons of fuel, and we're going to be traveling 10 nautical miles over the Earth's surface in order to get to 5,000 feet. But we're not going to 5,000 feet, and we're not going to 4,000 feet either. So we're going to get the number that's right in between. So for 4,500 feet, we're going to pick the number that's in between 6 and 8. So let's say 7 minutes to get to 4,500 feet. So let's take that number. Now we're getting into the time. So we have our airport top of climb is going to take us 7 minutes to get there, right? So in between here, we have the time, estimated time is 7 minutes. So I'll just put a 7 minutes right there. Now let's say we took off at, I don't know, let's say we took off at 12 o'clock. So put 12 o'clock right there and 7 minutes. So our estimated time of arrival is going to be 12:07. And you would do the same thing all the way down here too. Okay, so now let's go back to our, so we got our first information there. All right, so let's see, 5,000, so we had 8.7. So now we need our gallons used. So in between 1.5 and 1.9, let's just use 1.7. So we're going to subtract 1.7 for our fuel. So here's our fuel. So we're going to subtract, put a little minus sign there, 1.7. Now lastly, we have our last one, the distance in nautical miles. So let's take the number in between 8 and 10, and that's 9. So we're going to put a, for the distance, leg is going to be 9. We're going to put 9 right there. 9. Now, notice how it takes us 9 miles to get all the way up there. And remember, the total distance in between Ormond and Flagler was 10. So if it takes us 9 miles to get all the way up to our top of climb, how much more miles do we have to fly in order to get to K-Fin? Well, 9 plus 1 is 10. So top of climb in Flagler is going to be 1. And this is going to equal out each other. Now we can actually add all of these up, but we still need our top of descent. So before we get into the top of before we get there, let's go ahead and try to get our true airspeed. So that is how you're going to be using this. Now, if you have small notes, this is going to be very important when you're doing your weight and balance. For example, down here it says add 1.4 gallons of fuel for engine start, taxi, and takeoff allowance. Right? Because when you start off your engine, you know you're using fuel too. So make sure you take that away when you're doing your weight and balance. On top of that, what you can also do is you can add this in here to this as well. So 1.7, get my little, and then you can get your handy dandy calculator. So we have a 1.7 plus our 1.4, it says right there, add 1.4 gallons for fuel, engine start, taxi, and takeoff. So you can add that because you're using that up too as well, right? So you can add 1.4, and there you go. So now it's 3.1. So what you can do is you can either put a 1.7 there, or you can actually just put minus 3.1. However, wait, there's more. What about your engine run-up? We also do an engine run-up too, right? That also takes up fuel. To err on the side of caution, what I recommend is you just add a gallon on there. Just add an extra gallon. I know it's overkill. Maybe to be more realistic, you can put maybe half a gallon, or maybe not even that. But the reason why I do a half a gallon is because just in case if I get there and the mags are a little rough or whatever, and I have to burn off the mags, you're going to be sitting there for a little bit longer. So that's why I always put either 1 gallon. So you get the 3.1 plus the 1 extra gallon for the engine run-up, and now you have 4.1. So if you want, this is not mandatory or anything like that, but it's just my recommendation that you add all that up and you subtract that for the very first fuel burn. Because by the time you get to your top of climb, I mean, you can't get to your top of climb without doing a run-up, without taxiing, without starting up your engine, right? So all that fuel is going to be subtracted there anyway. So what I'd recommend is instead of doing 1.7, I would put 4.1. So minus 4.1, and that'll make these calculations that much more realistic. To the next page. And now we have our cruise performance. All right. Now, let's say we're cruising at, so here's our cruising altitudes right here. Again, we can do some interpolations because again, it's 4,000 feet and this is the performance, the cruise performance for 6,000 feet. Now, how do we read this? Because normally, because it says right here, 20 degrees Celsius below standard temp, and it has these other three columns for 20 degrees above standard temp. So how to read this is, so 4,000 feet, and we can interpolate, let's just say 4,000 since it's only 500 feet more than this. So let's just use this chart right here. These three columns, we have our engine power, we have our true airspeed, and then we have our gallons per hour, and that resets itself. Our percentage power, our true airspeed, gallons, percentage power, true airspeed, gallons, gallons per hour. And notice it separates in columns for 20 degrees below standard temperature and standard temperature, or 20 degrees above standard temperature. So let's say we are at 4,000 feet. What is the temperature at 4,000 feet? Remember our winds aloft information? So, and we interpolated. So at 4,500 feet, we interpolated the temperature to be at 16 degrees Celsius, right? So now let's see what it's supposed to be at 4,500 feet. Is it supposed to be at 16? No, it's supposed to be at 6 because that's in between 7 and 5. In between 4,000 feet, 5,000 feet, that's a 6 right there. So that's 6 degrees. But if it's supposed to be at 6 and our temperature is at 16, then that means the temperature is 10 degrees above the standard temperature. 10 degrees above the standard temperature. So we're going to be using these center three columns because 16 degrees is not 20 degrees below the standard temperature at 4,000 feet. And it's not 20 degrees above the standard temperature at 4,000 feet. Or whatever altitude that you're going to be picking. So that's how to read these three charts. So most of the time, unless you're living in the Arctic or in the equator, 9 times out of 10, you're going to be using these center columns, and that's why. So since we have our center column, we're going to be using these numbers right in here, all right? Because it's, again, standard temperature. 16 degrees is not 200 degrees above or 20 degrees below the standard temperature at 4,000 feet. So we're going to be using this middle column right here. Now, we need to find out what RPM settings we're going to be using. So for the RPMs that I normally use is at 2,300 RPMs. It's good for the engine. So that's the RPM I'm going to use. So what we're going to do is we're going to find the RPM that we're going to use. So 2,300. We're going to slide over to our middle column right here. Our true airspeed is going to be 102, and our gallons per hour is going to be 7.7. Let's use these two numbers. So a true airspeed, 102, and gallons per hour, 7.7. So 102. Now this descent is not going to be 102 because we're not going to be descending at 102 knots. Up here, remember that our climb was 73 knots. Okay, so we're going to use that for 73 knots. And our descent, we'll get back to the descent here momentarily. But for now, let's go ahead and calculate our wind correction angle and all that good stuff. While we're getting this, we're also going to be getting our ground speed as well for this first one. So wind correction angle, remember this 2 chord is going to be the same as this one. So let's go ahead and pre-fill in this one. So 334, 334. So now we're going to be getting our, so that's all of our true course. Now we're going to be getting into our wind correction angle, and this is where we start to use dun dun dun. Anyway, all right. So it's a lot easier than you think. All you have to do is just read the instructions, which is right up here. Okay. How I like to set this is, so this little center hole here, if you look really closely, you're going to see numbers on the side. So you see 180, 170, 160, all the way down. Find the arc that says 100 and put that right in the center. That's going to make calculations so much easier. So there's 100 right there. Okay, right there. Try to get as accurate as you can. You may see that I have a little tape right here. And I'll show you why I use this tape instead of using a pencil mark. I don't know whether the videos or whatever your other instructors have told you, you got to use a little pen or whatever. I don't really like using a pen or a pencil because then you got to erase it and it just causes a big mess. This is a lot more cleaner. Just get a piece of tape, just get a little piece of tape, fold it over, put a little X on there, a little dot, and to erase, done, erase. It's so much easier. Anyway, so we're gonna read the top instructions. So it says, set wind direction under index. Okay, under the true index. So here's our true index, which is right there. So our wind direction for this first one is 030 at 10 knots. So 030. So just move this to 030. You're going to twist this, twist until you have 030 centered right there, and just like that. The next one, okay, what does the next instruction say? It says mark wind velocity up from center point. Up from center point. Now what that means is, remember, your center point is right there. So if our wind velocity is 10, oops, let me bring this down. If our wind velocity is 10, then that means we're going to be marking 10 ticks up from the center point. 10 ticks up. And that's why it's so much easier to put this on 100, because 10 up is just 110. Just put a dot right there on 110. So what I'm going to do is I'm going to put this mark right up at 110. I'm going to try to put it right there. There it is, 110, just like that. Now, next, what's the next step say? Set true course under true index. Okay, so what is our true course? Again, we're going back to our course here. So our true course is 334. So now we're going to put 334 underneath the true index. So 334, which is right about there, 334. So there's 334 right there, right underneath the true index. Finally, well, not really finally, but slide wind velocity mark to true airspeed. Now this is where the confusion kind of goes, like wind velocity mark. What's the wind velocity mark? Remember, in step number 2, mark wind velocity. So that's what it means. That's your wind velocity mark. Your wind velocity mark is this right here, the little X right there. Okay, slide this to the true airspeed. So now you're still using these numbers at true airspeed. So what is our true airspeed? It's going to be 73 knots. So well, pretty close to 73. This is actually, the POH actually, it says indicated airspeed, but our airplane is so slow at that. I mean, the true airspeed and the calibrated airspeed and the indicated airspeed is really close. So it's fine. You can just use that for your true airspeed. So I'm going to slide this X over a 73. So 73. Move this. So there it is. See right there. Can you see that that's at 100? Okay. This is at 90. So there's 90, 80, 70. So here's 70 right there, but we're not at 70, we're at 73. So I'm going to go up to about right about there. Okay. All right. Now the last step is, it says ground speed now reads under the center. So what that means is our center point, whatever number that is now our ground speed. That right there is our ground speed. So whatever number that is, which is going to be, I would say, geez, like 66, I want to say. 66? Execute order 66. Okay, cool. Anyway, so 66. So that's going to be our ground speed. So what I'm going to do is I'm going to, for ground speed, for our top of climb, this is going to be 66, ground speed estimated. So I'm going to put 66 on the top here, and that's going to be right there. Now our wind correction, okay, anything to the right, you're going to add, anything to the left, you're going to subtract. So notice that this is the middle line right here. Just go straight up and down, just straight up and down. Let me go ahead and zoom this in a little bit more. All right, cool. So this line right here is going to be straight up and down. So anything to the right of this line, you're going to add. Anything to the left, you're going to subtract. So notice our line right here is already to the right, so we're going to be adding. And if you forget, you also have it says it right here too. So right add, left subtract. Has it right there for you so you can remember. So since it is to the right, you know we're going to be adding something here. So I'm going to put a little plus sign, but how much do we add? All right, so now we're not concerned about the lines going left and right. We're more concerned about the lines going straight up and down. So if we look really closely here, we have this number right here. So this line goes right up, and you have a 10 right there. This line represents 10 degrees. This line represents 20 degrees. This line represents 30. And each line in between is intervals, equal intervals, to get to 20. For example, if there's 5, so there's 1, 2, 3, 4. Actually, how many? 1, 2, 3, 4. So that means each line represents 2. So this is 12. This line is 12, 14, 16, 18, and then you get 20, 22, 24, 26, 28, 30. So that's what these lines are. Whatever this X, whatever line that this X comes over, that is going to be your wind correction. So we have 10 degrees and we have 0. So what's going to go up here? Remember, each one of these lines represents 2. So we have 2, 4, 6. So there it is. Your wind correction is a positive, since it's on the right side, 6. So we write right here, positive 6 right there. All right, and now we just do the math. So we got 334 plus 6. That means that's going to be equal to 340. Again, remember that little zigzag going up and down, up, down, up, down, up, down. Well, that's how this is going to work. So 334, we got our wind correction angle of 6 is 340. Now we get our variation lines. Now we're going to go back to our sectional. All right, so now we're going to be going over our variation lines on our sectional chart. Now, the sectional chart is oriented to true north. So that's how you can see how these lines are going straight up and down. Well, that's going to be your true north. Now the Earth is actually tilted, as we all know. So here's our Earth. So here's our true north right here. True north, or yeah, true north. However, our magnetic is kind of off, right? So here's our magnetic field right here. This is going to be our magnetic north. So it's kind of off a little bit. So here's our true north right here, and then here's our magnetic north, like this right there. Now notice, if you zoom in a little bit, if I can circle, oh, what letter is that right there? Oh, looks like a V, right? Well, that's a little hint. Hey, hopefully that'll help you remember when it comes to variation. That'll mean the difference between your true north and then your magnetic. Your magnetic north. Now, if you look really closely, here's the true north right here, and if you look just slightly over here, you're going to see your variation line, which is right here. I don't know if you can see that right there, that line that goes down right there. It says 6W, and if you remember, west is best, east is least. So if you have a 6 west, west is best, meaning that you add. Okay, so that's our variation line right there. So 6. So we're going to add 6 to our variation line. So a variation line is, and again, if you forget, it says right there. So negative E plus W. So west is best. We're going to add 6. 340 plus 6 equals 346. 6. Now you're going to take this number and you're going to go into your airplane and find your deviation compass card, and whatever number is closest to 346, you're going to look at 346 and find out the correction, the deviation, and that's what number you're going to add or subtract there, and that's how you're going to get your final course heading, which is right there, and that's the course you're going to be flying, not 334. Look how due to the winds, look how much that changed. So that's why you definitely don't ever want to, okay, well, it's 334. Well, I'm going to fly 334 for 7 minutes, and I should be right there. Well, no, due to the winds, you're going to be pushed off course. So that's why it's very important to make sure you do all your wind corrections and everything like that. And it's the same thing all the way down. It's just rinse and repeat, rinse and repeat, rinse and repeat. Okay, and then we're going to take one last break before we go ahead and finish this up. When we come back, we're going to find out how to get the estimated time of arrivals and all this good stuff here, because notice that we have the POH gave us these numbers, right, for the top of climb. However, once we get up there, now how are we going to get these numbers? Because the POH doesn't give us this. And also when we get back, I will go ahead and fill up most of this when we come back, and then you can pause the screen and you can actually match up your numbers to mine and see, you know, if you got the same numbers. And then when we also come back, we're going to go over how we do the top of descent, and then we'll go ahead and finish up this lesson. So go ahead and pause the video now, take 15 minutes, and I'll see you back in 15. And I'll do this one last one too. Here's just a little bonus. I mean, you can probably watch this while you're taking your break, but I'm going to go ahead and do this next one, just in case you missed something. I'm going to be using the same method pretty much. So instead of 03010, I'm going to do the same how to do the wind correction angle using a different doing the second one. So we're going to go down to 080 at 10. Again, make sure that this is at 100. This is going to be erased. All right, so 080 at 10. Again, 10 degrees, I'm sorry, 10 knots up. So we're going to count to 10 from the center hole. Make sure that it's at 080 because that's the wind direction at 10 knots. So 10 above our center hole. Mark that right. Mark that right there. Okay. Now the next step, set to course under the index. So our true course is going to be 334. That's next. So we're going to move this over 334. Notice how the whole thing is just moving over. So 334. And this is, yeah, 334. And now we're going to move this again. Slide wind velocity to mark to true airspeed. What's our true airspeed going to be? It's going to be 102. So now we're going to move this to over 102. So it's pretty much already there right now. So yeah, let me move it up a little bit. There we go. I guess that's 102. All right. So now we have our wind correction. It's to the right, so we have to add something, right? So how much do we add? Again, we have 0, we have 10 degrees, right? How many lines are in between there? We got 10, I'm sorry, 2, 4, 6, 8, 10. So each of these lines represent 2. So 2, it's about 2 right there. I would say 2. So I'm going to put a plus 2 right here. Plus 2, 334 plus 2 is 336. The variation line is going to be exactly the same. We're using the same exact variation line because this variation line, let me move this over, this variation line right here, if you can see it, that one right there. The next one is way over there, and the other one is way far. So the closest one that's relevant to us is going to be 6. So this whole area we can use the same exact variation line. So I'm gonna add plus 6, So 336 plus 6 is going to be 342. And then again, you just rinse and repeat all the way down. Okay, we're back from the break, and I went ahead and pre-filled out this. I'm going to go ahead and zoom in. So if you try to fill this out on the break, you can go. Let me zoom in as best I can here. There you go. You can go ahead and pause the video there and see if you got roughly around the same thing. Okay. All right. So let me zoom out here again. All right, so now how do we get these numbers here? So now what we're going to be doing is we're going to be taking the same thing, and now we're going to be flipping this bad boy over and going to be using this side. Most importantly, we're going to be focusing on these little equations right here. So set in knots, this is our speed right here. And see this little arrow? That arrow represents this right there. That's that arrow. Okay. And then distance, outer, time, inner. What does that even mean? So the outer, it's talking about these numbers out here in the outer ring. So when you flip this around, the outer ring does not move. It doesn't move. The inner, however, that's the numbers inside. So the outer, like for example, right here, you see the outer is 20 and the inner is 22. Another thing about this, the E6B, is this can represent 20. It can represent 200. It can represent 2000, 2.0, 0.2, 2.000. So that's something that you're going to have to differentiate yourself and just make sense of what you're looking at. So let's go ahead and do this one, for example, after my camera kind of focuses in here. So we're going to be using what we have so far. So what we have is we have our distance and we have our ground speed. So distance, ground speed, but we don't have time. So we got to solve for x, right? So we have our distance, we have our distance, we have our speed. So let's put our speed over the arrow. So our speed is going to be, ground speed is 104. That's what we have written right there. So we're going to put this arrow right here at 104. So we're going to, there's 100. 105 is right there, so let's put it at 104 right there. Now we're going to sit there and hold it right there. We're going to move it. We're going to keep it right there, because if we move it, we throw off the equation, right? So our distance is 1, right? So we have our distance, which is 1. So we're going to find 1 on the outer. Find distance 1 on the outer. So we're going to find 1. Again, 1 can represent 1, 10, 100. Or this 10 right here can represent 1, 1.0, 1,000, 100, a million. So we're going to be using this as our 1 because there's no other outside thing that says 1. So that's why we're going to be using this one. Now if we look in the inner, what do we have? Time in the inner. So when we move in the inner scale, look at that, we have 55, something between 55 and 60. So we have to make sense of this. It's going to take us 55, that means 55 minutes, 55 hours, 55 seconds. Well, make sense of this. So we have, well, it's actually not 55. It's let's say 55, 6, let's say 57, right? 57, 58, let's say 57. All right. So we found out it says 57. We're flying 104 knots and we're going 1 mile. It's definitely not going to take us 55 minutes to fly 1 mile if we're going 104 knots. It's probably going to take us less than a minute, which is why it's showing the 55. So we have to see how we have to translate this ourselves. So we're going to put 57 seconds, or you can just put 1 minute. You can round it off. It's whichever you want to do. But right here for the ETE, we're going to put we're just going to put 1 minute. So 1 minute right there. Over here, now we have estimated time of arrival. So if our top of climb was at 12:07, because remember we left at 12:07 took us 7 minutes to get to our top of climb. If it takes us 1 minute to get to the next point, well then that means we're going to add 1 minute to 12:07. So ETA is going to be 12. Okay, now we got to find out the fuel that we burned during that time. So we're going to use the bottom part in the fuel because now we have our gallons per hour. We know what that is. We have our total gallons that we're going to be using. That's what we're going to try to solve, which we don't have yet. But we do have the time. We have the time from this equation. So let's set our gallons per hour. Do you remember what our gallons per hour was? Remember, we set that. Oh, actually, you know what? We wait, forgot to put that. Wasn't it 7.7? So it was 23. Yeah, 7.7. So we're going to put 7.7 up there. Okay. So let's go down here again. Let's flip this up right. So gallons per hour. So we're going to put that at 7.7. So let's go ahead and try to find 7.7. So here's 7 and 8. Let's put that right about there. All right. 7.7. And now we do the same thing. Time is in the inner. So if the time was 1 minute, right? 1 minute. We're going to find the time in the inner this time. So we're going to find that 1, which is right there. And we're going to have the fuel on the outer. So if there's 1, there it is. It's about 13. So we're going to use 13 gallons of fuel. Does that make sense? We have 13 gallons, 1.3 gallons, 0.13 gallons. Well, if it's just 1 minute, it's probably going to be 0.13 of a gallon. So that's how we have that right there. Another way how you can tell, another little way you can do this too, is you can take your gallons per hour, 7.7, okay, multiply that by 60. Now every minute that passes, that's how much fuel burn that you're going to have. And since it's 1 minute, oh, look at that, it kind of matches, doesn't it? It's pretty close to 0.13. So if we flew for, I don't know, 15 minutes, then you multiply that by 15, and there's your fuel burn right there, 1.9 gallons of fuel. And of course, you can just round that off to 2 if you want to err on the side of caution. But anyway, so that is how you do that. Let's do one more before we get down to our top of descent. All right, so we're going to do one more. All right, so this time we're going to be going 12 miles, okay? So 12 miles, and we have a ground speed of 108. So again, we're going to be using this equation right here. Ground speed is, what was it, 108. So 108, we're going to move this over to 108. So there's 100, there's 105, 106, 7, 8. Let's just say that's 108. Okay, we're gonna hold that right there. We're not going to move it. We're going to use this distance. So our distance was how much? 12 miles. So we're going to have our distance on the outer. So we're going to find 12 on the outer, which is right there. And then what was going to be on the inner? Our time. So our time is going to be around, let's see, there's 60, 65, so about, let's see. So it looks like it's going to be 67 seconds. Or is it going to be 6 minutes? Or almost about maybe over 6.5 minutes. I would say most likely probably a little over 6.5 minutes. And that's how that's going to work, because there's 60, there's 70, so 6 minutes, 7 minutes. So it's probably going to be in between 6 and 7 minutes. So I would say roughly around 6 minutes and maybe 40 seconds-ish. But again, err on the side of caution. You can round that off to 7 minutes. You can do however you would like it. But what I'm going to do is I'm going to put about 6.5 minutes. So just to make the math a little bit easier. So right here, I'm going to put 6.5, 30 seconds. And again, you would do the same thing here. So 6:30. So you add 6 on that, and then you would get, okay? And then after that, you get there at 12:13. Now, there's not enough space to add the extra half hour, 30 seconds in there. So you can actually round that off if you want to say 14 in there instead, which is what I'm going to do. So 12:14. That's the time I'm going to be expecting to get there. Now that we have the time, let's do the fuel burn. So again, now that we have the time, we're going to do this one. So I set our fuel burn to 7.7. Move this to 7.5, 6, 7. Hold it right there. We're going to move this. Our total gallons is in the outer. That's what we're looking for. So we're going to have our time, which is 6.5 minutes. So we're going to have our time in the inner. So let's find 6.5 in the inner. There's 6, 5, 6.5 is going to be right there. So we're going to be using, let's see, almost 8.5 gallons. So 8.5 gallons of fuel. But does that make sense? Let's go ahead and use the calculator to see if that calculation was right. So again, 7.7, and I guess you can do it this way instead of using it, but at least you know how to, if you need to prove that you know how to use that for your checkride, that's, at least you know how to do it. But let's go ahead and check our math. So 7.7, divide that by 60, and we're going to multiply that by 6.5, and that's going to give us 0.83. Now let's go ahead and go back to, let's see if we can make sense of this. So 0.83, again, 7.7. And we've flown for 6.5 minutes. So 6.5 was right about there. And then we go up to, let's see, it says 8. It's almost around 8.4-ish, 8.4, but it can't be 8.4. So let's move the decimal back, and it's about a 0.83 or 0.84. And sure enough, our calculations are correct. So that is why we're going to put, for the gallons used, negative 0.8. All right. And then you just rinse and repeat all the way down. Now when you're when you're flying, that's only when you're actually going to be inputting this number, the actual estimated, the actual time, or the actual fuel burn that you've done. And how you're going to calculate the fuel burn? Well, that's where you're going to be doing this in the air. And once we're done with the top of descent, I'll show you a really nice feature that you can put up here that'll help you with your deviations, because you will have to do a deviation while you're in the air, while you're flying, while you're trying to maintain the altitude, while you're looking out for traffic, while the examiner is looking at you, writing down. The pressure is on at that time, so you definitely want to take as much stress out of it as you can, and I'll show you some tricks to do that after this. So let's go into top of descent and how to do that. Okay, cool. So now we're going to be talking about top of descent. So the issue we have here is how, once we're up here at our 4,500 feet, when do we start descending away from the airport? Now notice how I have a descent and I level off at 1,000 feet. This is traffic pattern altitude. Why do I want to have this included? Well, because you don't want to keep descending. You don't want to keep going and then descending right down into the airport, because that never ever happens. You're always going to be descending down to a traffic pattern altitude, then you're going to be joining the pattern, and then you're going to be landing. You're always going to be at traffic pattern altitude. So you kind of want to set your plane and your aircraft up already at that altitude prior to getting into the airport environment. So that's why I recommend that you do your top of descent only down to 1,000 feet, and then you're going to get vectored around the airport when you get close to the airport environment. So question is, we have to find out how far away do we start our descent? How fast are we going to be descending? What's going to be our descent rate? So these are two simple equations that you can remember. So we're going to be doing these two things. So how much altitude are you going to be descending? From 4,500 feet, how much altitude do we have to descend down to get to 1,000 feet? That's 3,500 feet, right? So we're going to do 3,500 feet divided by the feet per minute. I recommend that you have a default descent rate at 500 feet per minute. If you have passengers, their ears won't be popping, your ears won't be popping. If you are going to be doing your instrument rating after this, I highly recommend you just default your descent rate at 500, because most likely your descent rate when you're doing your instrument is going to be roughly around the same rate too. So if you already have a habit of descending at 500 feet per minute, that's going to set you up for success. So 500 feet is going to be below here, okay, and equals 3,500 feet divided by your descent rate of 500 is going to be equal to 7. Okay, so we're going to keep that number. We're going to keep that number. We're going to come back to it. Now we're going to have our descent speed. Again, just like how I recommend you descend at 500 feet per minute. I'd recommend that you start descending at 90 knots. 90 knots, again, that's a default to descend when you're doing your instrument. If you're gonna press on to do instrument after this, I recommend that you just start practicing descending at 90 knots. So our descent speed is 90 knots. So we have 90 knots over 60 seconds. So 90 divided by 60 is going to be 1.5. Now, what do we do with these two numbers? We multiply them. So 7 times 1.5 is going to be 10.5. That is going to be your top of descent. When you're 10.5 miles away, if you descend at 500 feet per minute at 90 knots at 10.5 miles away, you're going to be right on point at 1,000 feet before you get to your airport. So your top of descent is going to be 10.5. All right, and so now that we know how we do our top of descent, now remember, between Melrose and Gainesville, we have 17 miles to play with, okay? So the good thing that our top of descent is less than this. That way, that means we don't have to descend before we hit Melrose. So going back to the chart here, so 10.5 miles we have to start our descent. So where can we actually start to descend? Again, I recommended that we start descending before we get into the airport environment. You see this little dash line? Here's about 4 miles out. This is Delta airspace. So I'd recommend that we already be down here at 1,000 feet before we reach this. So what we're going to do is we're going to actually measure 10.5 from here outwards, and that's where we're going to find our top of descent. So let's take our handy dandy little plotter here, and we're going to measure 10.5. Oh, that's going to be right at Melrose. Look at that. So there's 10. Again, I'm starting at this little line here because I want to be at 1,000 feet when I'm right here. It's 5, 10, 10.5. So we're at about there. Right about there is the top of descent. T-O-D right there. Now what we can do, now that we have that measurement, we're going to measure how far do we have to fly away from Melrose to start our descent. That looks like it's just going to be like 1 mile. Yeah, just 1 mile. So 1 mile. So for our distance, Melrose to our top of descent is going to be 1 mile. So our distance, we're going to put 1, and then that's going to be our top of descent, and then the rest of the way is going to be 16 miles. So we can just put 16 right here, because 16 plus 1 is going to be 17. So that is how we do our calculations for this. All right, so in order to get our ground speed, it's probably not going to be 90, okay? Don't make that mistake. What we're going to be using is we're going to be using our ground speed. Now our indicator is going to be 90, correct? However, due to our due to the wind, that's going to mess with our ground speed. And that's going to be a hint for my next little tip at the end of this video. The wind will affect your ground speed, and then we're going to have to do something with deviations when your examiner does throw that deviation to you when you're doing your check ride. But anyway, let's get our true ground speed when we're starting to descend. So let's go back to what we learned earlier today. So we're going to put our wind. We're going to follow this. So set wind direction under true index. So our wind direction is 060. So we're going to put this, oh look at that, it's already at 060. So 060, just like that. And now next one, mark wind velocity up from center point. Again, before we do that, let's go ahead and put the center at 100. Okay, mark a wind velocity up from center point. Wind's velocity is 7, so I'm going to make this mark right at 7, which is right about there. Yeah, that's close enough. All right, and now we we slide the we set the true course. So our true course is going to be 275. So we move this to 275. All right, 275, which is right there, and then finally move this to the indicated speed, which is going to be 90. So we move that mark to 90 knots, which is right there. It's 90 knots. Now our ground speed is right underneath the center point, just like we learned earlier. Now, because of the winds, our ground speed is not going to be 90. It's actually going to be closer to 95. So we're going to change this to 95. Don't make that mistake. There's a lot of mistakes there. All right. And that's how you get your true ground speed. Now, of course, the times where all you have to do is just rinse and repeat for everything else. And that's how you fill out this whole chart right there. Now that we have all of our distances, let's go ahead and add up all these up and find out what we can put for up here. All right, so I got 9 plus 1 plus 12 plus 17 plus 14 plus 1 plus 16 is going to equal 70. All right, so I got 70. Totals down here can be 70. Okay, and then you do the same thing all the way down here. So once you get all your times down here, you can calculate the times and then add it up there, and then you can see exactly what time you're going to arrive there with the winds and everything like that. And then you can estimate what time you're going to be there. Same thing with the fuel burn. So I'm going to actually fill all this in so we can actually get the information we need to do our weight and balance. So once you learn how to do all of this through here, learn how to do it this way first. I definitely recommend. But now, you know, take advantage of technology. So if you use the Sporties app, and I have, let's see, I have some apps here. So here is the Sporties app. It looks like that. So you want to hit that, and now you have all of these. Options. It's literally I think it's called Sporties E6B. But we want to find time, right? We already have our ground speed. We already have our distance. So let's find the option here where we want to find our flight time. So leg time, hit leg time, and there it is. We got our distance 17. So you plug that in, 17. And our ground speed is 112. So you plug in 17, put in your ground speed of 112, and there's your time right there. So 9 minutes and 6 seconds. So I'll just put 9 minutes there. And you can do the same thing for the rest of them too. So you can put 9 minutes. Okay, let's do the next one. So next one is we have 14 miles at a ground speed of 112. So same thing. We're going to put distance of 14 miles, and then our ground speed is going to be 112. Same thing. So 112. Oh, okay, cool. There it is. So 7 minutes and 30. So let's just put 8 minutes just to round it off. So 8, and then you just work your way on down. Now let's do the same thing for fuel burn. So fuel burn, the same thing. We have let's see, our endurance fuel. Where is fuel burn? Oh, there it is. Fuel required. Hit that. Fuel required. So we have, so our time is 9 minutes. We have that now. So let's go ahead and put that in there. 9 minutes. Oops, not 90. There it is, 9 minutes. Gallons per hour, we know it's 7.7. So 7.7, and there it is. That's how much fuel that you're going to be burning. So 1.2, you can go ahead and put that in here. So subtract 1.2 gallons, do the same thing all the way down. All right, we have made it. We've done it. So we filled out the entire thing. Now again, the only thing that's going to be missing is this right here, because we can't really fill this out because we don't have the deviation card. So look at your deviation card and your compass to fill in this blank right here, and then that's how you're going to fill in these numbers right here. So what I've done, you can go ahead and let me go ahead and zoom in really quick so you can actually check mine to see if it matches yours. So what I did is I went ahead and I plugged in these numbers. Sorry about my little chicken scratch, but so I just added up 7 minutes plus 1 minute, 6.5, 9, all that added up to about 41 minutes of flight time. So on this day, with these weather conditions, at this set RPM, if everything works, I will get there in exactly 41 minutes. Now, and of course, that's without being vectored or anything like that. Obviously, once you get in the airspace, you're going to be vectored, and that's going to add a little bit more time. But that's going to be your estimated time and how you're going to get there. Again, with the fuel, all I did was I added all of these up, and your total fuel burn is going to be 9.8 gallons. So when you're doing your weight and balance, that's about 60 pounds of fuel that you're going to be needing. Now, again, that's not including your 30 minutes of extra time for reserve that you're going to need for VFR day flights, or the 45 minutes extra that you're going to need on your night flights. So I highly recommend that you put little notes in here or up here or on your weight and balance chart, so you can actually see why you've added or whatever, so you can reason, because you're going to have all these numbers here, and then your examiner is going to ask, he's going to point to the randomest thing that you've calculated, and he or she's going to ask you, like, okay, well, how did you get that number? Like, oh geez, and now you're trying to fumble through and how to remember. So just write small little notes on that. Use the back of the sheet too if you want. And that is pretty much it. Again, these right here, you're going to fill these out too. Fill out all this information for the departure and destination on your airport. And then finally, we're going to close out with my deviation card that I recommend you have on every single one of your navigation logs, especially for your checkride, because this is going to be night and day difference when they ask you to divert somewhere. Okay, so we're finally here, and we're going to close out with this big tip here. It is a big tip, so let me and also I would like you to go back to SkyVector and look at the numbers, because remember when we moved that little magenta line, it all automatically gave us the heading and the distances or whatever. So use those numbers to back up if you have your information correct as well as using that Sporties app to make sure you have the right information over here too. But do this by hand first. Get used to knowing how to do this, because I think it'll be kind of embarrassing if you went for your whole pilot training and still not know how to use one of these. So so I definitely recommend you learn how to use this first before you hit up the cheating apps and stuff like that. I'm not opposed to using technology, but I am opposed to relying on that extra technology. So so now the cheat code that I recommend you put up here is give yourself, this is called a deviation compass rose that I recommend every single pilot use. All right, so we got north, south, west, east. Okay, now wind direction. If you're flying heading, let's say 342 or whatever heading that our true course right here, we already have our wind correction and everything like that, so we know we have to head, we know that if we fly, let's see, on this heading for 12 miles, we're going to get there in 6 minutes. If you didn't have this information, well, now I need my ground speed. Well, how am I going to get my ground speed? So you have to have all of this information while you're in the air, while you're trying to maintain altitude and everything like that. So if you already have this information ahead of time, regardless of what direction you're flying, wouldn't it be convenient to have your ground speeds at every single direction? So say if you're flying this way and you have to divert to the south, well, you don't have your ground speed to the south yet. So that's what this compass rose, this wind compass rose is right here that I recommend every single person do. So what we're going to do is we're going to have our airspeed. We're going to have everything already calculated. So what I did right here is oops, let me go ahead and reset this. So what I did is, let me put this over. All right, so what I did is I did the first two steps. So I put the wind 080. Why? Because that's what the wind direction is. 080, 080, 080, 080 at 10 knots, 10 knots, 10 knots, 10 knots. So this whole area. So this would work. This calculation will work for this whole area right here. So 080, mark it up 10 from the center. Again, have the center over 100, 10 up. Now it says to move it to the true course. But what we're interested in is, let's say we had to go north as our true course. So let's set this to north. Set that to north. It's at north. Now we're going to move our wind velocity marker to our airspeed, right? So our true airspeed is going to be 102. So let's move this to 102, which is pretty much already there. Yeah, it's pretty much already there. Okay, and now our ground speed. So if we go north, true airspeed at 102, our ground speed is going to be, what is that? Let me see. Looks like 101. I want to say 101-ish. Again, we're looking at the center hole right there. So let's say 101. So going north, our ground speed with the wind correction, with the winds and everything is going to be 101. So put 101 right there. Okay. Now we're going to do the same thing to east. Just slide it over to east. It's very easy. Just slide this right over to east. Rinse and repeat. Move that down to 102. So we're going to move this down to 102, which is right about there. Now, what's our ground speed moving east? Ground speed looks like it's going to be, looks like that's 93-ish, I guess. So going east, ground speed is 93. Same thing. South, rinse and repeat. Going south. Okay, move that to 102. This time we're going upwards. 102. Now our ground speed looks like it's about 102. So going south, 102, and then finally west. We're going to go to the west. Oops, west. Move this to our 102. Now our ground speed moved up to about 112. So 112. Now these are our ground speeds. Now of course when we have a tailwind, when the wind's behind us, we're going to be moving faster. When the wind is coming at us, we're going to be moving slower. So you can tell moving this way, moving east, we're going to be moving slower. So the wind must be moving this way, right? Moving this way. Oh, look at that. Look at our wind. It sure is. It's coming from 080. So that matches what we have here. Now how can you use this to your advantage? Let's say we are moving up here. All right, so we're going up this way. We're going this way. So our ground speed is going to be, our ground speed is going to be around somewhere between 112 and 101. Oh, look at that. 104, 108, 112, 112. So it matches, right? However, let's say you get it right around here and something happens and your examiner asks you to divert to, let's say, I don't know, Pearson, which is like right there, okay? So that is actually southwest. So now, crap, now I gotta do this and everything. I gotta fiddle with this to get my ground speed, because I need to get my ground speed in order to get my time, and I need my time in order to get my fuel rate, right? Well, if you already have this, you got the first step already knocked out. You know you're going southwest. Again, use that interpolation skill that we learned earlier. So if you're going southwest, your ground speed is going to be roughly between 102 and 112. Now you can do this for as many directions as you want. So if this is too much to interpolate, well, let's get one for southwest. You do the same exact thing. So move this to a heading of 230. That's going to be southwest. Move this to your 102. And you see how easy that this is. So now our ground speed is going to be 109-ish. So 109. This right here is 109. And again, you can do it over here in northeast, northwest. So that is going to be very convenient. So let's say we do have to divert. How far is it going to be? Use your thumb. Know how far your thumb is on the scale. So mine is roughly about, let's say, I don't know, close to, so I'm just going to use my fingernail there. There it is. So it's about 5 nautical miles right there, right? So if we are here and we divert to Pearson, I'm just going to use my thumb. So let's see, 5, 10, 15, 20, about 20 miles. Okay, 20 miles. My ground speed is 109. How long am I going to get there? I already have the ground speed from right there, 109. Just move this to 109. Spell it right there. Yeah, 109. Okay, and then we have our our distance in the outer, which is 20. We go to 20, and then there it is. That's how long it's going to take us to get there. Okay, cool. Now that we have our time, and then we do the same thing for our gallons per hour, and that's how we can tell easily how much fuel that you're going to be burning. If you don't have this, you're going to have to get your ground speed the old-fashioned way, which is you're going to have to get your sectional. You're going to have to measure a point. Let's say you're here, you have to fly 5 nautical miles, let's say from here to there. Okay, so you're going to pick a point right there. Hopefully you can see that, and you're going to time it. You're going to time how long it's going to get you to get from there to there. So that you have the time. So this is where you don't have this, and you're trying to get this. So you have the time and the distance. So let's say the distance is 5 miles. So you're going to have your distance out here, which is 5. So you have your 5 right there. There's your 5. And then let's say it took you, I don't know, let's say 2 minutes to get there. So you're going to rotate the inner to have 2 right underneath your 5. There's 2 right there. And if that's the case, then it's going to point at your ground speed, which is probably 150 knots. So that's how you get your ground speed. But you can eliminate that whole step if you just do the win card right there. So so yeah, I hope you enjoyed, and that was so that's how to fill out this whole VFR cross-country chart. All right, aviators, so that is how you properly complete a VFR flight plan from start to finish. Watch this video as many times as you need to. I know there's a lot of information. If you have any questions, you can go ahead and email me, fly@aeronerdaviation.com. I also do online courses as well. Now, this is actually a pre-recorded, obviously pre-recorded video, but if you actually need a little bit more instruction, we can actually talk one-on-one. All you have to do is schedule an appointment. Just email me, fly@aeronerdaviation.com, and again, we can go over anything that you need to step by step. So again, I hope you enjoyed this video, and I'll see you guys in the next session.